Okay, so we'll talk about standard position of angles today. So what does that mean exactly? Well, a standard position of an angle is essentially a representation of an angle in a Cartesian plane with a ray from the origin. So like that. So there's a few pieces of terminology you should know first. And first one is the initial arm. The initial arm, it's just standardized, is always the positive x-axis. It's always this part here. This is the initial arm. And then there's a terminal arm. The terminal arm is a ray coming from the origin. Between the terminal arm and the initial arm, an angle is formed, and let's call that theta. So the directionality does matter in this representation. An angle that goes counterclockwise will be positive. An angle that goes counterclockwise will be negative. And note how there could actually be two angles formed right now from this terminal arm, because another one go from behind and go this way. Let's call it theta 1 and let's call this theta 2. And note that theta 2 is negative. Now these two angles are called coterminal angles because they share the same terminal arm. And actually there are an infinite number of coterminal angles, since you can keep on adding one full rotation or subtracting one full rotation. In fact, theta 2 here is just equal to theta 1 minus 360 degrees, right? Theta 1 subtract 360, you'll end up back here. So coterminal angles are just related by 360 degrees. For example, we have an angle here, let's say the terminal arm is here, an angle of 135 degrees here. You're asked to find some coterminal angles. Well, you can do 135 degrees plus 360 degrees. That gives us 495 degrees. That would be like this. And it's coterminal. Let me change the color. That would be 495 degrees. Now remember, subtracting also works. So we can do 135 degrees, subtract 360 degrees, and that would give us negative 225 degrees. And that would give us the angle here. Let me change the color. It's negative 225 degrees. So those are some important ideas surrounding coterminal angles. But this also has implications in drawing angles in standard position. Say you're asked to draw negative 13 pi by 6 radians. Well, that seems pretty complicated, so where do we start? Well, first notice that this is more than a full rotation. A full rotation would be 2 pi radians. This is more than that. Or in this case, negative 2 pi is also a full rotation, just going clockwise. Let's split it up into that full rotation and another component. This part is the full rotation, and we're left with negative pi by 6. So when we're drawing, if we put in a full negative 2 pi rotation, it's going to look like this. And guess what? We're back where we started. So that's kind of redundant. So in fact, we can ignore this. Instead, let's focus on graphing this section. Negative pi by 6, it's around here. It's also 30 degrees if that's more intuitive. This is negative pi by 6. And that's the angle, and that's how you would draw it in standard position. But you should actually label it, shouldn't label it negative pi by 6. Should still label it negative 12 pi by 6. Sorry, negative 13 pi by 6. And the angle should be drawn fully. But that's sort of the steps you would take to draw these larger angles. And remember, if it's 2 rotations over, you would take out both of those rotations and just draw what's left over. Now, there is also another really important factor here that you should know, and that's called a reference angle. A reference angle is just the angle formed between the terminal arm and the x-axis, always the x-axis. So in this case, our reference angle is here. It is in fact pi by 6. Now notice it's not negative, and that's because reference angles are always positive. It's always a positive value that is acute and lies between the x-axis and the terminal arm. So let's draw a few more examples. If you have an arm here, the reference angle would be here. If you have an arm here, the reference angle is just the angle of that terminal arm, but it's over here. So if your angle isn't acute, if it's not between the x-axis and the terminal arm, you might want to double check that. To find the reference angle, you can just use the idea of supplementary angles. So say we have an arm over here, and this is, let's just say 150 degrees. Well, then what's the reference angle here? Well, you know that the flat line is 180 degrees. So therefore this section, this reference angle, has to equal 180 degrees minus 150 degrees. It's 30 degrees. So our reference angle is 30 degrees here. If you have a reference angle, let's say here, and I'm gonna erase actually. Where if you have a reference angle here, and this is 200 degrees. Well, in this case, you would consider that this section is 180 degrees and determine the angle here. So it would equal 200 degrees minus 180 degrees. And it's 20 degrees. So this reference angle is 20 degrees. Let's do one more example in the last quadrant. Here, let's say you have an angle here. And you have, let's just say 300 degrees. Well, you know that the full rotation is 360 degrees. So this angle here has to be 360 degrees minus 300 degrees, which equals 60 degrees. So our reference angle is 60 degrees. Now, why is this important? Because it seems pretty random, right? Well, it helps you to determine trig ratios, which we'll talk about later. You would, to do like a trig ratio, like cos of 200 degrees, you would consider the reference angle to find the ratio, which is cos of 20 degrees. But it could be positive or negative, depending on the quadrat, but we'll talk about that later. So now let's practice some questions. Say we're asked to draw 2 pi by 3 radians. Two pi by 3 radians. Where would that be? Well, that's around 120 degrees, so let's just draw it here. This angle is 2 pi by 3. What would the reference be? The reference would be Note that this sort of by supplementary angles, this sort of straight angle is pi radians. So the reference angle would be pi radians minus 2 pi by 3 radians. And that gives us pi by 3. So our reference angle is pi by 3. Now, what would a coterminal angle be? Well, let's do a simple one. Let's just add a full rotation to our original value. So let's add to 2 pi. 2 pi by 3 plus 6 pi by 3. That's 2 pi. That would equal 8 pi by 3. So this would be a coterminal angle. And let's do another one. Let's say we're asked to graph negative 11 pi by 3 radians. So again, we can see that this is more than a full rotation, so we can split it up. So let's split it up. What would it be? You'd have negative 6 pi by 3. That's our full rotation. And you would have leftover negative 5 pi by 3. So if we try and draw that, we can ignore this full rotation. And remember that this angle is negative, so we're going to go clockwise. Negative 5 pi by 3 is 1 pi by 3 away from another full rotation, so that's easier. We can go by that. And draw it, say, here. So it looks something like this. This is right. I know it's here because it's pi by 3 away from a full rotation, 60 degrees away from a full 360 degrees. So it should be somewhere around here if we say this is 60 degrees. In fact, that gives us our reference angle too. Our reference angle here is pi by 6, or pi by 3, or 60 degrees.